Hello, everybody. In Module 4, I discuss communication games between managers and market. Module 4 has 6 lessons. Today, we're focused on Lesson 2, verifiable disclosure with strategic withholding. In the previous lesson, we talked about the classical unraveling result. It basically says that when the market knows that the manager has private information and disclosure is costless, then we'll have full disclosure. Because withholding information will be interpreted as having the worst news, or equivalently, market has the most pessimistic belief about non-disclosure. Today, we're going to see that if we relax those two assumptions, if disclosure is costly, or if the manager may not have private information, then withholding information cannot be interpreted as having the worst news, because withholding could mean that the manager may not have news, or the manager may have news that are not good enough to cover the disclosure costs, but certainly not the worst. So the market's belief upon non-disclosure would not be the most pessimistic belief. And this benefit of doubt results in some informed managers choose to strategically withhold their information or choose to be strategically silent. The discussions in this lesson are based on 3 papers: Verica 1983 JAE, Dai 1985 JAR, and John Quan 1988 JAR. So if you want more details, go check those papers. Let's first look at the setting with disclosure cost. Again, informed manager sells the firm to the uninformed market, and the manager chooses some disclosure strategy to maximize the selling price. Everybody is risk neutral, which means price is equal to expected firm value conditional on disclosure. There is no variance concerns. We assume that the firm value has a prior distribution, would mean U0 and precision H0. So before any disclosure, this is market's prior belief about firm value. The manager, of course, privately observes you because the manager is privately informed. The manager can choose to disclose or not. Any disclosure has to be truthful. In addition, any disclosure incurs a cost of C that is bigger than 0, and this C can be interpreted as proprietary cost. Now, to solve the model, when a firm discloses, the disclosure has to be truthful, and the firm incurs a disclosure cost. So the price is the disclosed signal U minus proprietary cost C. Of course, this price is increasing U. If the firm chooses not to disclose, then the price is P&D, the price upon non-disclosure that we talked about in the previous lesson. And this, of course, is independent of the realization of any signal for firms that do not disclose. So what this means is the firm is going to disclose if and only if U is bigger than some threshold, because the disclosure price is increasing U and the non-disclosure price is independent of U. Which means that when U equals X, the firm must be indifferent between disclosing and non-disclosing. So at the threshold X, we have X minus C, which is the payoff upon disclosing, to be equal to the payoff upon non-disclosure. Expectation of U conditional on U is smaller than X. And given normal distribution, this will be a truncated normal for the right-hand side. And you can use the formula for truncated normal distribution. You will get this equation that characterizes the threshold X. And of course, the PDF and CDF of standard normal distribution will be involved. So we can see here, there is no full disclosure because not all of the firm is going to disclose, even though they all have information. Disclosure will be threshold based. You're going to disclose if and only if the observed value is bigger than some threshold. We can rewrite the equation for threshold X as follows. The reason we're doing that is we can do some comparative statics. So the comparative statics we're interested in is how disclosure threshold varies with respect to the proprietary cost. So this transformation from X to T, we can show that T is increasing in the proprietary cost C. And because T is increasing X, so that means X also increases with respect to the proprietary cost C. That means higher proprietary cost results in less disclosure because you disclose only when the value is bigger than the threshold. So the higher the threshold, the less you disclose. And this is quite intuitive. And it underlines the motivation of a stream of empirical studies relating product market competition to voluntary disclosure. And the general idea is more competition by increasing the proprietary cost of disclosure would result in less disclosure. There are a lot of variations in how you measure product to market competition and how you measure voluntary disclosure, but the theoretical motivation comes from this setup. And the results are also very intuitive. A higher proprietary cost makes disclosure more costly because once you disclose, your cost has to be higher. That means you need better news to disclose to compensate with higher proprietary costs. That means you're going to disclose less. Now let's look at the second setting, when managers may not be informed. Again, the manager sells the firm to the markets, and the manager chooses the disclosure strategy to maximize the selling price. Let's assume the market has a prior belief of firm value X, some density function of F on the support between X lower bar and X upper bar, and say the mean is mu. The manager privately observes X with some probability 1 minus P, and the manager observes nothing with probability P. The manager can choose to disclose when it observes X, and the manager, of course, can choose to be silent. But if the manager chooses to disclose, any disclosure has to be truthful. And of course, if the manager observes nothing, the manager has to be silent. Now let's, again, see how we solve the model. If the manager discloses, because disclosure has to be truthful, market price is going to be X. If the manager does not disclose, again, the market price is some price conditional on non-disclosure, and that's independent of firm value, X. So again, the manager is going to adopt a threshold disclosure strategy. Manager is going to disclose if and only if X is bigger than some threshold Y. Again, only good news is disclosed. This threshold Y satisfies the condition that at this threshold, the manager is indifferent between disclosing and non-disclosing, which means that Y would equal to the price upon non-disclosure, or expectation of X conditional on non-disclosure. How do we calculate the expectation of X conditional on non-disclosure? We use Bayes' rule to do that. Non-disclosure has two possibilities. The first possibility, denoted by A, is when the firm is uninformed. Then, of course, the firm cannot disclose. The second possibility is B, when the firm is informed and not disclosing. So you calculate your expectation of X conditional on non-disclosure for those two cases. The expectation of X conditional on A times the probability of A conditional on non-disclosure plus expectation of X conditional on B times probability B conditional on non-disclosure. And the algebra in the slides provide a line-by-line derivation. And I'm not going to go through that other than pointing one thing out. The probability of non-disclosure has two events, A and B. So the probability of non-disclosure is the probability of A plus the probability of B. The probability of A occurring is P, when the firm is uninformed. The probability of event B occurring is the probability that the firm is informed times the probability that the firm is not disclosing. The firm being informed has probability 1 minus P. And the firm not disclosing means that the firm observes a value smaller than Y. And that occurs with probability Fy. So the probability of event B is 1 minus P times Fy. And we can show, if you want to look into the details, check the Zhao and Kwong paper. They use this trick called integration by parts. And eventually, they get the expression for the threshold. They show that the threshold is between X lower bar, the lowest possible realization of X, and the prior mean of X mu. And Y is characterized by this equation. And so here's the intuition. Because the firm could be uninformed. Investors give some benefit of doubt to non-disclosure. Non-disclosure could mean that the firm does not have information. And this allows managers with information to exploit such benefit of doubt and to choose not to disclose when they observe signals that are sufficiently low, which means that firms with sufficiently good news, they would prefer disclosing because their value upon disclosing is higher than the non-disclosure price. So they want a higher price. But firms with sufficiently bad news, they would exploit such benefit of doubt. So the disclosure threshold is smaller than the prior mean. So if you think about investors, they're naive. If they observe non-disclosure, they don't think about firms' disclosure strategies. They would just think the firm value upon non-disclosure would be the prior mean. But in this case, the threshold is smaller than the prior mean. So investors, they're skeptical, but they're not extremely skeptical about non-disclosure, as in the Grossman or Milgram case. So they know that the non-disclosure firms, their news must be bad, but it's not extremely bad to the lowest possible value. And now let's look at some comparative statics which provide empirical implications. The first comparative statics, if you decrease P, or equivalent if you increase 1 minus P, that decreases Y. So decreasing P or increasing 1 minus P, which means that the probability that a manager is informed increases. When a manager is more likely to be informed, there's less benefit of doubt. Because in this case, investor would attribute non-disclosure to be more likely to be that the manager is informed and observes some bad news. The investor skepticism is going to be high, which means that no disclosure price is going to be lower. Therefore, more firms would disclose. That's why the threshold is decreasing. Threshold decreasing means that more firm is going to disclose because firms would disclose when their observations are higher than the threshold. The second comparative statics related to the distributions of X. Suppose we have two distributions of X, and if one distribution dominates the other, either in terms of first order stochastic dominance or FOSD, or second order stochastic dominance or SOSD, then the distribution that dominates in terms of first order stochastic dominance or second order stochastic dominance has a higher threshold, so less disclosure. And here's the intuition. Either first order stochastic dominance or second order stochastic dominance means that distribution is better. Think about first order stochastic dominance as an example. First order stochastic dominance means that the prior distribution is more likely to be shifting to the right, which means that the prior expectation is going to be higher. So in that case, there'll be more benefit of doubt because if you do not disclose, I think there's some probability that you do not have any news. But if the distribution condition on you do not having any news is better, then I'm going to give you more benefit of doubt. So the no disclosure price is going to be higher. Therefore, less firms will disclose. The threshold will be higher. So the implications from those comparative statics are, first, firms voluntarily disclose good news and hide bad news. And that's because of the threshold disclosure strategy. You disclose only when your news are sufficiently good. The second is closer to the earnings announcement date. This is when the manager is more likely to be informed. Let's say if it's 3 months prior to the annual earnings announcement date, then the manager may not have much idea about some parts of the operations of the firm. But when you get closer to the earnings announcement date, the manager is more and more likely to be informed. So no disclosure is more likely to be attributed to bad news. Then the firm is more likely to disclose bad news. The third implication comes from comparative statics 2. If you have bad news from other sources, for example, from analysts or industry peers, is more likely to trigger firms disclosing bad news. And this is because bad news from other sources are going to make the distribution conditional on non-disclosure being worse. And so it's more likely to trigger firms disclosing bad news. To conclude, disclosure frictions, either there's disclosure cost or the market is uncertain whether or not the managers have information, is going to generate some benefit of doubt that allows managers with sufficiently bad news to be strategically silent, strategically withhold news. And the equilibrium is usually captured by some disclosure threshold. You're going to disclose if and only if news are sufficiently good. In this lesson, investors are skeptical about non-disclosure, but they're not skeptical about disclosure because it is assumed that if firms disclose anything, it has to be truthful. In the next lesson, we're going to see how to model investor skepticism about disclosure. If you want to have a test of your understanding of this lesson, check out the link of the quiz provided in the slides.